This is the Sea of Tranquility, the historic site where humans first walked on the moon. And this, surprisingly, is Arizona. At first glance, if these pictures weren't labeled, there would be almost no way to tell them apart. Each crater, each patch of terrain, seems identical down to the size and placement of every depression in the ground. This isn't a hoax, and it isn't some strange natural coincidence. This is real. This place was meticulously created by NASA to replicate the moon's surface here on Earth. With the help of explosives, a random field in Arizona was transformed almost instantly into what could be the most moon-like landscape on our planet. Today, decades later, much of it has been slowly reclaimed by nature, but its role in the Apollo program remains monumental. Why NASA recreated the moon on Earth in the late 1960s? NASA was on the brink of landing humans on the moon, yet despite the enormous technological strides of the time, they faced a major problem. They simply didn't know enough about the moon's surface. Back then, very little was known about how the moon formed or what materials covered its surface. The most detailed images available came from the lunar orbiter satellites, which offered a resolution of about 2 meters per pixel. That might sound precise, but in reality, it only allowed scientists to see the largest craters. The finer textures, the subtle details, and the distribution of rocks was still a mystery. For NASA, this posed a critical problem. Astronauts were about to become the first humans on the moon, and every second of their time there would be precious. Studying the rocks, craters, and soil could unlock vital information not just about the moon itself, but also about the history of Earth and the formation of our solar system. Maximizing scientific output from each mission was absolutely crucial. Enter Cinder Lake. What is the Cinder Lake crater field? Before astronauts could step foot on the moon, they needed to become experts in lunar geology. They had to look at a crater and immediately gauge its age. They had to describe rock formations, analyze soil, and collect samples with precision, all while navigating an alien landscape. NASA needed a realistic training ground, and Cinder Lake, a volcanic field near Flagstaff, Arizona, was ideal. Its terrain, covered in volcanic gravel, resembled what NASA believed to be the moon's surface. But simply finding a vaguely moon-like area wasn't enough. They needed to recreate the lunar landscape down to the exact size, placement, and age of craters. How NASA recreated the moon. The transformation was dramatic. NASA used dynamite to sculpt the Arizona field into a nearly exact replica of the Apollo 11 landing site. Each crater had to be carefully measured and positioned to match the lunar maps captured by the lunar orbiter satellites. But there was an added complexity. The craters had different ages. Using the principle of superposition, NASA scientists could determine which craters were older and which were newer. On the moon, a younger crater would overlap an older one, sometimes erasing part of the rim and leaving a fresh circle on top. To replicate this effect, the team in Arizona marked out 143 craters, categorizing them as old, intermediate, or new. Dynamite was placed under each site in precise amounts, and the team detonated them sequentially, starting with the oldest craters and progressing to the newest. In an instant, a barren field became a lifelike lunar surface, training astronauts to navigate the moon. One of the first challenges astronauts would face on the moon was simple but critical: navigation. While NASA had a planned landing zone, the lunar module could touch down anywhere within 5 kilometers of that target. Without a detailed understanding of the landscape, astronauts could easily wander off course and miss crucial scientific targets. This is where Cinder Lake proved invaluable. NASA placed a mock lunar module at a random location within the crater field. 28 test subjects, geologists, mathematicians, surveyors, and others, were given 30 minutes inside the module to locate themselves using satellite images of the moon. If they failed, progressively smaller maps were provided, narrowing the search zone. After 4 hours, one person had still not located the target. The results were enlightening. Only 6 of the 28 participants could identify their position using a 1-kilometer resolution map. 12 required the second map, 8 needed the third, 1 succeeded with the fourth, and 1 failed entirely. The best strategy for lunar navigation. NASA scientists analyzed the methods used by participants to determine what worked best. Some searched for lines of craters, thinking they would be more noticeable. Others tried memorizing groups of craters or complex patterns. Surprisingly, these strategies were less effective. The most successful method was identifying pairs of craters. Why? because a pair is easier for the human brain to remember than a complex array. Once the test subjects could locate a simple pair, they could use it as a reference point to orient themselves and map the surrounding area. Thanks to these exercises, NASA developed effective training protocols for astronauts. By the time they landed on the Moon, astronauts could confidently locate themselves and collect samples systematically. Training for science, not just survival on the Moon. Astronauts were more than explorers, they were the eyes, hands, and instruments of Earth-bound scientists. Every observation, every rock collected, could provide a glimpse into the Moon's ancient history. At Cinder Lake, geologists trained astronauts to identify rocks, describe terrain, and communicate findings clearly via radio. Even this communication posed challenges. It was difficult for scientists on Earth to fully grasp what astronauts were seeing and doing through radio alone. To solve this, NASA experimented with live video transmission from Cinder Lake, a concept that would later evolve into live broadcasts from every Moon mission. This breakthrough not only improved training, but also brought the public closer to space exploration than ever before. The legacy of Cinder Lake astronauts trained at Cinder Lake for years before the Apollo missions began. Their preparation paid off. Across 6 Apollo missions, astronauts returned with more than 380 kilograms of lunar samples, each carefully preserved for scientific study. These untouched rocks and soil continue to offer insights into the Moon's formation, the Earth-Moon relationship, and even the early history of the solar system. All of this, every sample, every observation, every critical insight, was made possible thanks to a small volcanic field in Arizona. It's a reminder that sometimes the greatest scientific achievements aren't born in space, but right here on Earth, in a place meticulously engineered to mimic another world. Why it matters today. Cinder Lake represents more than just training. It exemplifies NASA's approach to exploration, preparation, precision, and innovation. The field allowed astronauts to develop essential skills for survival and scientific research in a completely alien environment. It allowed scientists to test hypotheses about the Moon's geography, surface, and composition before risking human lives on the actual lunar surface. Without Cinder Lake, astronauts would have faced longer learning curves, and scientific discoveries may have been delayed or even missed entirely. It was the bridge between Earth and the Moon, a place where theory met practice and preparation met the unknown. Today, Cinder Lake has mostly returned to nature, its craters partially eroded and softened by decades of weather, but its contribution to human knowledge remains indelible. The field stands as a testament to human ingenuity, a place where explosives, geology, and human curiosity came together to prepare humanity for one of its most extraordinary achievements. In essence, this small field in Arizona reminds us of something profound. The Moon may be far away, but reaching it required not only rockets and astronauts, but also a deep understanding of science, meticulous planning, and the willingness to recreate another world right here on Earth. NASA's efforts at Cinder Lake were more than just a training exercise. They were a rehearsal for history. And when humans finally set foot on the Moon in 1969, it was the culmination of thousands of hours of preparation in a volcanic field thousands of miles away from the Sea of Tranquility. Every crater, every rock, every landscape feature that astronauts studied at Cinder Lake helped them navigate, survive, and observe the lunar surface with accuracy and precision. Without it, our understanding of the Moon might have been far less comprehensive. Thanks to this remarkable field, the Apollo missions were not only a technological triumph, they were a scientific triumph as well. So, the next time you look at the Moon, remember that some of what made that historic landing possible happened right here on Earth, in the heart of Arizona, in a little volcanic field where dynamite sculpted the surface to match a world far above our own.